Hi, this is Mrs. Rodriguez, your pre-algebra teacher. This video is about lesson 12-8, all about similar solids, okay? Let's go ahead and get started. All right, just a few things. So similar solids. So it talks about this piece of art, and it says in the 1800s, Edgar Degas created a wax sculpture of a young ballet dancer. The approximate height of the sculpture is 39 inches. Donice wants to purchase a model of a sculpture that is 13 inches tall. Okay, so the model and the sculpture have the same shape, but are different sizes. So the ratio of their corresponding parts is 1:3. So two figures are similar solids if they have the same shape and their corresponding linear measures are proportional, okay? So it says in an example, determine whether each pair of solids is similar. So the lengths have to be proportional to each other, okay? So we can set up a proportion and then solve the proportion and see if they are proportional, right? So the length of this side is 10 kilometers, and then the length of this side is 18 kilometers. So I want the corresponding side. So this side corresponds to this side on the second figure. So the 15 would go here. And then the 18 side corresponds to this side over here. That's 26 kilometers there. Okay, so then I'm going to cross multiply. And if they're equal to each other, then they are proportional. So 10 times 26 is 260, and then 18 times 15 is 270. Well, that is not equal, right? So no, these solids are not proportional to each other, okay? So therefore they are not similar, okay? All right, so let's look at these solids here. These are cones, okay? So we want to look at this side here, 11 2/10, the slant height, and then the radius is 7 2/10. Okay, these are yards. So the second solid, the slant height is 14 yards. So that goes up here because the slant height was up here. And then the radius is 9 yards. Okay, so then I would cross multiply. So 11.2 times 9 is 108/10, and then 7 2/10 times 14 is 108/10 as well. So that they are equal to each other. So yes, they are proportional. So that means yes, they are similar. Okay. All right. Now this example, it tells you the triangular prisms are similar, and it says to find the height of prism A. Okay. So we are comparing these two. We're going to set up a proportion. We have the height of the base, and we're also given the height of the prism. Okay, so let's set up our proportion. Okay, so first solid, the height of the base, which is the triangle, because this is a triangular prism, is 24 feet. Okay, and then the height of the prism, we don't have that value, so we're going to call that h. And then the second solid, prism B, we have the height of the base, the height of the triangle is 8, and then the height of the prism is this side here, which is 10. So then I'm going to cross multiply. I've got 8 times h, which is 8h, and 24 times 10, which is 240. Then I would divide both sides by 8, and h is equal to 30, and this is feet. Okay, so the height of that prism is 30 feet. Okay. All right, then finally in this section, it talks about the ratio of surface areas of similar solids and also the ratio of volume of the volumes of similar solids. So we can take the surface area of one solid over the surface area of another solid, and if we know their scale factor, then we can figure out one of these missing pieces, okay? All right, so let's take a look. So a cone has a surface area of 160 square inches. If the dimensions are reduced by a factor of 1/2, what is the surface area of the new cone? So we've got the surface area of the first cone, let's call it A, and then we're comparing that to the surface area of cone B, okay? So it says that it's reduced by a factor of 1/2. So that means the surface area of A is twice as big as the surface area of B. So that means our scale factor is going to be 2/1, okay? So it may seem kind of tricky because you might have thought, oh, well, 1/2 is the scale factor, but it says it's reduced by 1/2, okay? So that means the surface area of the cone A is larger than the surface area of cone B, okay? How much larger? 2 times as large, okay? So I'm going to take the surface area of cone A, and I don't know the surface area of cone B, and my scale factor is 2/1, okay? And over here it tells us you can set the surface areas equal to the scale factor squared, okay? So that means I have to square the scale factor, okay? So that's 160 over B is equal to, now remember I have to square the numerator and the denominator. So 2 squared is 4 and 1 squared is 1, okay? So now I have a proportion, so I can cross multiply. So I have 4B equals 160, and then I would divide both sides by 4. So B is equal to 40 inches squared. Okay. All right, so that's all for this lesson. Hopefully this video was helpful to you. Again, if you have any questions, of course, please call, text, email me, or stop by my office hours, and I'll be happy to help you. You have a great day.